What you're watching is a new state of matter in action. These ripples are molecules in a liquid crystal, flipping and turning as they react to lasers. And the cool thing about this is that you can actually see this with the naked eye. So what is it exactly? To help us understand, we first have to look at regular crystals up close. The atoms in crystals are arranged in what's called a lattice. That is, the atoms are positioned in a periodic manner. A salt crystal, for example, has sodium and chlorine atoms that alternate in space. But what if the atoms don't just alternate in their three dimensions, but also in the fourth, in time? This was first conceptualized by Nobel laureate Frank Wilczek in 2012, and he called it time crystals. His original idea consists of atoms in their lowest energy level that alternate states in time forever without ever absorbing or emitting energy. His idea was later proven to be impossible, but physicists soon realized that they could actually create alternative forms of time crystals. Since then, various experiments have been conducted to create them. One of the first experimental observations of time crystals is a 2017 Nature study in which US scientists used lasers to flip the spins of ytterbium ions. Another group in 2021 pumped microwaves to the qubits inside Google's quantum computer to simulate time crystals. Then, in the same year, scientists at the Max Planck Institute released the very first video recording of time crystals. This whole spin is made of nickel and iron alloy, and these dark and white bands are the changing spins of the atoms as captured by an X-ray microscope. But this experiment is incredibly tiny. This strip is only 11 micrometers long, even smaller than the width of the thinnest human hair. And that brings us to this. These ripples are the time crystal alternating in real time, and they're big enough to be able to see with the naked eye. This was created by scientists at CU Boulder using liquid crystals or material made of oval molecules that behaves both like a solid and a liquid. They placed the liquid crystal between two glass plates and shone a light onto it. As the liquid crystal reacts, the orientation of its molecules twist, creating the bright and dark bands you're seeing right now.